Good morning, everyone. Welcome to BodhiBrew, offering advantage through insight. I'm your host, Confidi Kong, Creative Director of Bodhi Research Group. In today's episode, we cover quantum computing and its application to finance with our solutions engineer, Dr. David Sabatini, and visiting researcher, Dr. Niall Whelan. We discuss the rapid evolution of quantum computing and its effects on the financial world. Dr. Niall Whelan, with a PhD from Yale University, is a risk executive with over 20 years of experience in areas that include climate scenario modeling, enterprise risk, enterprise stress testing, credit modeling, and models for market and counterparty credit risk. Dr. David Sabatini utilizes multidisciplinary skills and draws on interprofessional experience in the business, clinical, and engineering domains, including the development of a secure web-based educational software. So sit back, relax, and enjoy a cup of brew with us.
Hello, everyone. Welcome to BodhiBrew. My name is Dr. David Sabatini, and I'm here with Dr. Niall Whelan. And today we're going to be discussing quantum computing in finance. And it's a very relevant topic in today's world. And I'm just going to start. What is a quantum computer, Niall?
Yeah, so I first met the concept of quantum computer back in 1994. My background is in theoretical physics. I was at a physics symposium and I heard about this and I thought, wow, as a physics concept, this is really cool. Can see why this is really interesting to physicists. But I thought they were talking about some of the engineering problems. I said, you know what? They're never going to fix those engineering problems. So this will always be an interesting physics concept, but it'll never be anything that's really relevant out in the broader world. I think I may have been wrong on that, though. There have been enormous advances in the last, I don't know how far you want to go back, 10, 20 years, but more and more, it's like an avalanche right now of different devices, different technology. So, in essence, a quantum computer, by contrast to existing computers, which maybe we'll call classical, just to make the distinction, relies on two fundamental physics concepts, which are called entanglement and superposition. Don't really have time to get into all the nitty gritty of what those are, other than to say those are fundamentally quantum concepts. There's no classical analogy to those, and they allow for just incredibly powerful computation that's just inaccessible to a classical computer, that then opens up a whole world of possibilities about the sorts of things you can calculate and the sorts of computations that are just way beyond the scope of what a classical computer can do.
So are you saying we can sort of get supercomputing on a smaller machine without relying on a supercomputer?
Better. Even the best supercomputers in the world can't do some of the things that we think a quantum computer will be able to do.
S-
But
s-
this is still a little bit speculative because this is still emerging technology. So it is still a little bit, we're not sure whether these quantum computers are going to come to pass or not. But if they do, they will be wildly more powerful even than the best supercomputer that exists today.
Wow. So basically, we're talking about a supercomputer in every home, in every office.
Well, it's probably not going to be in your office. Almost certainly, this will be similar to the cloud computing model, where you would subscribe to a organization that hosts the computer, and then you would have access to it. And the reason for that is these typically require very advanced technology that is just not the sort of thing you would want to have in certainly in your home office or even in the basement of a bank or an institution. It really will almost certainly be something that resides in a technology firm, and then you as a service would then make use of it. Who
I see.
knows? 30 years from now, maybe that will change, but that's probably the best
So
guess
it'd
of
be sort of similar to sort of like an AWS cloud computing environment.
exactly.
Okay.
Yeah.
So how is that going to help us in finance?
Well, the potential applications of quantum computing is vast, and finance is would certainly participate in that. I think one of the applications that gets a lot of discussion out there in the wider community, even beyond finance, although it's certainly relevant for finance, is encryption and decryption. So classical computers today, when they communicate with one another, use certain protocols. Like when you log into your bank account, for example, you'll put in a secure password, and that password is incredibly secure. The technology behind that is rock solid. So to break that for someone to snoop in and listen to what you type to your bank and then try to figure out what your bank account is on paper a solvable problem, but it would take a modern computer, a classical computer, longer than the lifetime of the universe to actually infer your password given what they can see that you communicate to the bank. So that's the basis of modern um, cryptography, and it underlies our entire society, really. I mean, not just finance, although finance will be part of it, but every time you log into any account, your bank account, you log into your healthcare provider, anything like that, you're conveying very sensitive information, and it is secure. The way it's not secure is not by cracking passwords, but by phishing expeditions and other sorts of things. But in terms of the underlying being able to break the password, it can't be done with a classical computer. Turns out a quantum computer, if we could build one that was powerful enough, could do that. Could figure out your password.
Okay, so hold on a second here. What I'm hearing now is I cannot rely on the infrastructure that's already in place once there's a quantum computer in play.
That's correct.
So now, if I think back, all my security protocols, everything that I'm basing all my businesses on, these could all be at risk because given the correct hardware and the correct software, an agent that wants to do me harm could potentially do me harm.
Yeah. It's even worse than that.
Explain?
Okay. It is worse than that in the following sense. We do not have, okay, it's better than that in the sense that we do not have a quantum computer today that can do that. But
Okay.
what we do know is that on paper, if we could build a powerful enough quantum computer, there exist algorithms that could do this. So right now we're just waiting for those quantum computers. So they don't exist yet. So that's the sense in which it's better. But the sense in which it's dangerous even today is if somebody were to grab, say, an encrypted database of very sensitive information, they could do
Okay.
that today, presumably, if they could get a hold of your
So if they get a
system.
hold of my database
Yeah.
and
And they could potentially just park it somewhere. They can't decrypt it. It's just a bunch of random zeros and ones to them today. But then if they think, oh, but I'm going to have a quantum computer in 20 years' time, and I'll decrypt it then. So I'll grab the data now, decrypt it in 20 years' time. So then the question is, are you concerned about data that you have today that maybe could be decrypted 20 years from now?
oh, I see.
And it depends 100% on what sort of data you're talking about. So if you're talking about your health data, do you want your health data being made available 20 years from now? Perhaps not. If you are a trading firm, do you care about your trading positions today being visible 20 years from now? You probably couldn't care less because, you turn over the portfolio with much faster frequency than that. But there are certain people who have data today, like the
That is
government.
static. It's more static over time.
Sorry, I don't understand.
So very similar to you were saying, like your health data. You might have
Mm,
my health number, for example, or even
right.
social insurance numbers that end up being encrypted on various databases and that various platforms. That
Yes.
doesn't tend to change over time.
No.
But like you were saying, something like trading information, like how valuable is it something that's 20 years old? But this other information that tends to be static over time
Right.
is vulnerable. And you're saying that there are vulnerabilities now that are going to be increasingly vulnerable to quantum computing.
That's right. And that's the concern people have.
Okay, so that opens up a whole variety of other questions here. My first one would be, would that be irregardless of what about the blockchain? From my knowledge of the blockchain, that's relatively secure, and a lot of financial institutions and pension plans, they're using high level encryption, even military grade encryption.
Right.
You're saying that this is potentially all at risk with quantum computing.
Yes. But it's not all doom and gloom. As we speak, in the US, the National Institute for Standards and Technology, it's a US government body, is just in the final stages of selecting what will be the next type of
Level
encryption.
of encryption.
And that is the term that is used for that is quantum safe. The algorithms which are used right now, which are vulnerable to quantum computers, there are other algorithms out there that one could use for encrypting and decrypting data, which are what is called quantum safe. In other words, there do not exist analogous quantum algorithms that can break that. So the quantum computer wouldn't have any advantage over a classical computer in breaking a quantum safe algorithm. So they exist mathematically. We know that there are potential ways that one can do this. And the challenge isn't actually rolling that out. Any new standard, we would have to all agree on doing it as a society. Every institution, every user has to get on board with this new technology. And so we know that that will take a long time. That might take 20 years or so. So then the concern is just a question of timescales. If it takes us 20 years to implement these new algorithms and some bad actors grabbing your data right now, and you think that in 20 years' time they'll have a quantum computer, is that concerning to you or not? And it really, as I said earlier, gets back to what kind of data are you talking about? Static data, yes. I mean, obviously, governments would be very concerned. They would, the US government right now is presumably doing all sorts of things that they would not want people knowing about even 20 years from now. So it's a really interesting problem, and this conversation is supposed to be about finance. We haven't spent much time talking about finance, but obviously finance as part of society is as vulnerable to this as anybody else. So I think this is sort of the killer app of quantum computers, is the encryption and decryption, and is the topic that people spend a lot of time talking about. But there's plenty of finance specific
Okay.
applications too.
So what are some of the finance specific applications that you're aware of that could really benefit the various levels of finance?
Yeah, so I think we could think of this in sort of three broad buckets. There are applications which can help you make more money. There are applications which could potentially save you money. And then there are applications which could just help you make better decisions. And I think we can sort of think of it in these three buckets. So there are lots of potential applications of quantum computers in terms of things which can help save me or make me money, pardon me, that was my first category. I would say one area that we know quantum computers are quite good at is optimization. So basically, if you have some problem with a large number of constraints and you have some sort of utility function that you want to get optimized, subject to all of these constraints, that is a hard problem. Just as a computer science problem, that's a hard problem and is a direct application to portfolio optimization, for example. How do I choose which assets I want to include in a portfolio? And that sort of problem is, in fact, very amenable to quantum computers. Exist quantum algorithms which are much faster than existing classical ones for solving that sort of problem.
So we're talking about pension plans, institutional investors. They're optimizing their various portfolios,
Yes,
and you're using you'd be using a cloud-based provider
probably. Yes.
as opposed to having your own quantum computer in order to make these portfolio decisions almost in real time. Am I getting that correct? That you're able to, because your computer has the potential to be so quick
Right.
that you're going to be able to handle complex variables almost in real time to be able to make those sort of active management decisions. Am I on the right track?
Yeah, 100%. It's a competition. I mean, even right now, it's a competition because the classical computers can give you an approximate solution. So it's a question of how fast do you want an answer versus how good do you want the answer to be. And so there is a
There's still a trade-off.
competition. There's a trade-off there. The thing with quantum computers is that they push the envelope. So you can either
I
have the
see.
same quality decision faster, or you could have, for the same amount of time, a better answer. So you still have a choice, where am I going to put what do I want to optimize? But it just will allow you just to do this whole calculation faster. So you can either get it faster or get it better.
So it's almost, from what I'm hearing, it's almost like a competition between somebody running a portfolio right now with an advanced classical computer
Right?
versus going back 70 years ago and somebody running a portfolio with pen and paper and slide rules. Is
Yeah, exactly.
or
Yeah.
is it even worse than that? A bigger advantage, maybe?
We don't really know yet. It depends how good these the hardware gets. The other thing we don't know, which is sort of interesting, there's a whole world of work going on just on the hardware, trying to build these things, but also on the software side. When we think about classical computers and the sort of programs and algorithms we put on classical computers to solve problems of interest to finance, in many ways it's fairly mature. I mean, we continue to refine algorithms and make them a little bit better, but most of the base machinery is pretty established, and then people are just tweaking it on the edges to make it better. Whereas with quantum computers, on the software side, we're also seeing that it's very greenfield, if you will. There's a huge opportunity space to make these algorithms even better. So we don't even know between how good the hardware can get and how good the software can get. We don't even know how much better a quantum computer could be. And just one example, for example, we were talking earlier about the encryption and decryption. That first idea that you could use a quantum computer for that problem was first written down in 1994, so almost
Oh,
30
wow.
years old. Somebody just a month ago, in October of 2023, published a way to do it that was 1,000 times faster.
Wow.
So, and we've got no fundamental reason to think that's the limit, you know. So there's huge potential for both the hardware and the software to speed that up. So what is that? How much better could a quantum computer be than a classical? We don't know.
I see. What about trading? Just what you were mentioning, portfolio optimization. Then immediately I started to think about the various processes of trading, and that's something that could be very systematic in many shops right now around the world. This seems to be something that could really revolutionize trading. W-
Yeah, potentially. You're thinking algorithmic
I'm
trading here?
thinking algorithmic
Right.
trading. I'm thinking breaking down all the different pieces of the sort of the trading methodology that different platforms would be using. Um, what kind of advantages, like speed advantages, come to mind immediately? Do you foresee any other ones?
Well, the algorithmic trading is a great example, I think, because there you are trying to respond in milliseconds or faster to movements and signals in the market. And to do that, there's an absolute advantage. If we're both algorithmic traders and my computer is just that little bit faster than yours, and I can make decisions and execute just that little bit faster than you,
I'm dead.
you're dead. It's not
Yeah.
yeah, it's a step function
Yeah.
difference in how we perform. So even a slight advantage is outsized in terms of its impact on relative performance in that space. So again, we're being speculative with these
Yeah.
quantum computers because the technology is not there yet, but yeah, absolutely. If you could create a quantum computer that could give you that signal and give you that answer 1 beat faster, then that could be a game changer.
So the more I talk with you, the more questions I have in my head. So here's another one
It's a
that just,
great topic, isn't it?
it's unbelievable. The next question that pops in my head goes something like this. You immediately recognize that it's just a huge space with hardware, software, physics, engineering, finance, modeling, all kinds of different disciplines that are sort of merging together.
Mhm.
If I was going to begin to implement this in my own shop, it's very
Okay.
difficult to have that cross discipline expertise that
Yes.
is required to sort of work this quantum computing and finance on a professional level.
Yes.
How much should I invest in this right now? How much should I be concerned? What should I be reading? What should I be doing? Who should I be talking to?
Okay, that's a great question. There are a lot of firms that are partnering up right now because they realize, you know, JP Morgan, for example, doesn't necessarily have a lot of quantum physicists on staff. I mean, if they do, they have them accidentally because they're people like you and me who studied physics but
Yeah.
then entered finance. But what a lot of them are doing now are actually partnering up. So you'll see, for example, a firm out of Vancouver that just announced they have the first 1,000 quantum bit computer. They've crossed that 1,000 threshold.
What's
There's
the name of that firm?
photonics.
Photonics. Okay.
And they just got financing from Microsoft, for
Okay.
example. So Microsoft realizes, oh, I can leverage the knowledge they have and their hardware base, but I'm Microsoft. I've got big, deep pockets and bundles of money. So I think that you're starting to see more and more partnerships like that, where a lot of the big banks, the big financial institutions, and the big technology companies are partnering up with some of these smaller, sort of innovative, small startups in this space. So that is one way in which financial institutions are getting their hands into it. I don't know if that was quite your question or if you just said if you were a small shop, how you would do it or what.
Uh, The next thing that popped to mind
Right.
is how much am I exposing myself to algorithms and software development and hardware that I do not control? I'm a person that likes to sort of lock down what I
Right.
have and make sure that I'm protected well.
Right.
Um, and I see a fundamental difference between having a computer or a set of computers that is on site in my own building that I
Ah,
control with my own IT staff
yes.
versus something that's offsite.
Right.
And it seems like a black box to me. Is what kind of a risk do you see that,
Well, you're raising two sort of different points, I think. Correct me if you disagree with my interpretation. But one question is just off-siting,
yeah,
and the other is it a black box or not? Those are
yeah,
sort of separate questions.
100%. Oh yeah, address them
So,
both.
the offsite, well, I mean that ship has sailed, right? I mean, all major financial institutions use cloud-based computing and have been doing that for a long, long time. And initially, there was a lot of concern around like security. How do I know that I feel much safer if my IT department has their arms wrapped around my
Exactly.
system? But really, do you think in-house IT system is better than Microsoft's or
That's a
or
good point.
Amazon? And I think a lot of I mean, I used to work at a large financial institution here in Canada. I think at some point they got comfortable. You know what? We don't have in-house. It's not like we're any better at this than these big firms, and probably, in fact, they're more on top of these things.
Mm.
So I think in terms of the offshore, I don't know, offshore isn't quite the word, but just making it off-prem, I think that is sort of a solved problem, if you will. I think people have wrapped their heads around it. They realize it's no more dangerous than on-prem. Um, but then in terms of your second half of your question around the black box nature of it, well, again, I mean, if you think about classical computers, right now there's an awfully large code base of code that's out there that you can pull out of, software repositories like GitHub and so on that is often black box and you're just putting things on top of it. And certainly when you look at getting a little away from quantum computing, but yeah, when you look at some of the generative AI, for example, you can create machine learning tools that can just create code for you. And so this is all moving very fast and not even in the quantum regime. So I don't see these being I don't see
Not quantum specific, you're
yeah,
saying.
I don't see the fact that you're doing this in a quantum way either adds or detracts from this problem or your concerns, I guess.
So let me just take a step back and just sort of reiterate what I think you're saying.
Mhm.
So what I'm hearing is that we outsource this function to, these technical providers
Right?
that are experts in their field. I don't have to worry so much about the hardware because it's up to them to, as we increase the qubits, as we increase the processing capability of those quantum computers, we might, what we can do today, 2 years from now, we may be able to do 1,000 times or 1,000,000 times
Right.
what we can do today. But that's their responsibility to change computers and update the hardware,
Theirs being the service
the
providers.
service
Yeah.
provider. And as far as the software development, the quantum safe algorithms that are
Right.
running on this constantly improving hardware,
Yep.
that's their responsibility as well.
Mhm.
I'm just taking advantage of the capabilities to make me
Right.
more money.
Yes. And I should also point out that just as happens today with cloud services, you still own your IP. I mean, if you wrote a program that you use to analyze and optimize your portfolio, it's yours. I
I
mean,
see.
you own the code. The code. So it's not that the fact that you've outsourced it takes away from your. If you have a secret sauce, if you have a particularly good algorithm, you had some really smart people who came in and did something in a really clever way. That's yours.
It's
You could
still there.
patent it if you want, or keep it in house and use it. So that doesn't change.
So let's jump before you had mentioned making money. I guess we talked a little bit about that.
Yes.
What about saving money? How can quantum computers help me to save money as an institution?
Well, I mean, think about any way in which having better IT would save you money in the sense of if the extent that you can automate processes that are currently manual or to the extent that you can do the same task with less resources of insofar as a quantum computer could help you with
So
this
you're thinking accounting, auditing, those
accounting,
kinds of things,
auditing,
back office kind of procedures.
yeah, yeah, a lot of that sort of nuts and bolts of running an operation. Due diligence might be another
I see.
example.
So
Either Mhm.
how would due diligence? How would you save money with due diligence?
There are a number of aspects that one needs to do with due diligence, like For example, legal due diligence. So right now you'll see classical computers with machine learning code doing sort of text, reading text and interpreting text and condensing text. And you see that happening in general in the legal profession, where things are getting more and more automated, just to the extent that a quantum computer could potentially do this better than a classical computer.
I
That's
see.
all I mean. Yeah. So just
So
continuing that journey.
you mentioned one word there that you
Uh-huh.
mentioned machine learning and AI.
Yes.
So now we're merging AI and machine learning with quantum computing.
Yes, we are. Turns out there exist quantum algorithms that can dramatically speed up machine learning and AI as well.
Wow. I guess that would lead right into the better decision making.
It would. So certainly the machine learning and AI would be one. There is also, like when we think about risk management, an awful lot of risk management, which is obviously a critical function at any sort of significant asset manager. A lot of their models, a lot of their processes rely on a particular algorithm called Monte Carlo, which just requires that you just randomly sample whatever it is that you're trying to analyze, like market fluctuations, and you just simulate the market by randomly projecting different potential futures. And then you average over that, and in that way, try to come up with some sort of aggregate view of what could happen. Or at least, what's the 10% worst thing that could happen, for example. It turns out, though, that Monte Carlo is very, very inefficient. If I want to improve my accuracy by a factor of 10, I would need to run 100 times more random guesses to get
I
a
see.
factor of 10. It scales like a square, which is really bad. There exist quantum algorithms that scale linearly. So, and it's not uncommon that for some risk processes, you might run hundreds of millions of random guesses to build up your distribution. And so, rather than hundreds of millions, you're now talking tens of thousands, which is a speed up of tens of thousands. So even if your quantum computer is a little bit slower, if the algorithm that it is running is 10,000 times faster, you're still coming out ahead. So there's all sort, and and the application of Monte Carlo is endemic throughout, finance applications, particularly in the risk space,
So we can make money,
right?
we can save money, we can make better decisions,
Yes.
but it comes at the cost that it's a evolving landscape that's changing very, very rapidly. And you need to be able to ask the right questions at the right time to the right people to make an informed decision for your own institution. Would that be a fair statement?
That would be a fair statement. It's also very interesting. I might just close out on the fact that it's also an interesting asset class to be thinking about. The number of firms that are in this space is somewhat small, but growing. The amount of dollars that are being invested in this space is growing exponentially. It's gone up by a factor of 10 just in the last 5 or 6 years. So the huge capital flows are going into this. And it's certainly as an opportunity for investment. A lot of small little firms out there that are hungry and wanting to grow and have big, big ambitions.
And it's not going anywhere.
I don't think so.
Thank you for your time, Niall.
No,
It
great
was a
conversation.
great discussion.